how are you? Already I have make a video related to GIS substations. Please see this video. Before posting this video or before viewing this video, you have to watch this GIS video to get more knowledge about GIS substations. Then see this video for your better understanding and better information sharing to your friends and anywhere you want to share. So SLD, what is SLD? It is the single line diagram of GIS substation, gas insulated substation. What is G? Is the gas. Gas is here SF6, sulfur hexafluoride. Gas insulated substations. So all the instrument, all the CT, isolator, circuit breaker, voltage transformers, earth switch, everything inside the pipe, circular pipe, and inside the circular pipe different assembly and different module are connected with each other to form a bus, to form a bay. Today I discussed about few bays that are being connected to the GIS gas insulated switch gear for feeder purpose, for incomer purpose, for transformer purpose, etc. I discussed about 220 kV GIS substations. In the 220 kV GIS substation, two number of buses are present, bus 1, bus 2. Here bus 1, this GIS pipeline has been connected with this disconnector switch, and this disconnector switch are just parallelly connected with this disconnector switch of the main bus 2. Main bus 2 disconnector, that is isolator, main bus 1 disconnector, that is also the isolator. Both are open now. This is the circuit breaker parallelly connected with both the buses, common circuit breaker. Then the current transformer, CT current transformer. Again the disconnector is an isolator with the earth switch. If necessary, we will put in service. This is the voltage transformers. Again the earth switch. If necessary, we will put this earth on in service. Then cable termination. It may be the cable termination. It may be the bushing, SF6 to air bushing for connection with the CVT, LA, and going to the section tower or transmissions tower. As per the bay, the structure of the GIS are different. So this is a general idea about a bay of the GIS system. First bus 1, bus 2, second disconnector, third circuit breaker, fourth current transformers, again disconnector. It is in the AIS system, it is the line side isolator. These both two are the main bus side isolator, and this is the voltage transformers. It may be the CVT, capacitive voltage transformer for communication purpose, or it may be the voltage transformer for taking the voltage, input and output voltage. And it is also the earth switch. If necessary for earthing, it will be put in service. And this is the cable termination. It may be the cable termination for the outgoing bay, and it may be the bushing for incoming side of the 160 MVA transformer for conversion to the 132 kV. So this is a one bay. one bay of the GIS system. You should have to remember that GIS systems has no transfer bus scheme. No TBC, transfer bus coupler, is not present. No transfer bus and no TBC present in GIS system. You have to put a single feeder, single transformer bay or whatever be in the two system, bus 1 connection, bus 2 connection. If you are connecting as per the nomenclature of the bay or feeder, suppose it is connected to the power grid 2, suppose it is connected to the PG2. So we have to connect this line as per our identification purpose with the bus 2. Bus 2 are connected with the bus 2 feeder and bus 1 will be connected with the bus 1 feeder. If it is the power grid PGCIL 1, so it will be connected to the bus 1 for taking power to the bus. That was the simple diagram, and it is the complex diagram. This is the incoming is just incoming is just coming through this bay, and the power is just feeding to the main bus 1 and bus 2. Then again bus 1 and bus 2 are connected with the bus coupler. Here the bus coupler concept is present in the GIS system, but no TBC, transfer bus coupler, is not present. If any breaker will be in problem, so we have no way to overcome this breaker or feed this particular feeder. Have to switch off this breaker or isolate these sections and contact with the manufacturers for further rectifications job. It is the disadvantage of the GIS systems. So the bus coupler is present here. The bus coupler is connected with, as per we have already been discussed about it, this is the main bus 1 and this is the main bus 2. Suppose it is 245 kV 2000 ampere main bus 1, 40 kilo ampere for 3 seconds, and it is also main bus 2 for 40 kilo ampere for 3 seconds, and these connections are just coming from PGCIL 1, Power Grid Corporation of India Limited. It is coming to the substation, incoming line. This is the incoming one. So suppose the first is the tower here tower section ST is the section tower. From the section tower it is coming to the LA and then CVT, and then it is just connected with the 220 kV SF6 to air bushing, and then the bus duct. From the bus duct it is also connected with this duct will be continued all the parts, main bus and all the instruments are inside the duct. So this is the bus duct is coming from outside to inside, and this inside is disconnector, earth switch, CT, circuit breaker, and parallelly connected both disconnector for main bus 1 and main bus 2. The power is coming here. So it is 1, so we will feed the power to the main bus 1 from the power grid 1, and from the power grid 2 we will feed the power to the main bus 2. So the incoming are just coming from power grid 1 to main bus 1, power grid 2 to main bus 2, and these two power are parallelly connected by help of a bus coupler, or here connected parallel circuit breaker. And here we can see here that two disconnectors are present coming from the two buses, and again two earth switches present. If necessary we will put in service both CTs present for bus 1 and bus 2, and a circuit breaker 2000 ampere circuit breaker is put in service for paralleling these two buses or two line. Okay. For getting the voltage of the main bus 1, what type of voltage magnitudes are coming from the power grid, we will put in service the PT1 and also the PT2. PT1 for the main bus 1 and PT2 for the main bus 2. Here for the PT, a high speed isolator is present here. Here also a disconnector or isolator is present here, and again this is the PT. This is the 220 kV by 110 volt PT. Here this is also the PT, this is also the PT. So now we will discuss today about the 220 kV bus and 220 kV instrument of the GIS substation, and also the 132 kV system has both two buses system. Here also the no transfer bus and no TBC are present. As like as the 220 kV systems, the 132 kV systems are same, but 220 kV system is more complex because these buses has three phases and three bus duct is present for R, for Y, for B. For R, Y and B, three bus duct is present. R separate individual, it also individual. So 6 bus duct is present for the 220 kV system, and for 132 kV system a single big rounded shape bus duct is present, and inside the RYB bar are just inside it. So for the 132 kV system it is very simple, and for 220 kV system it is very complex. So the idea is same, connection is same for one, and from here we are connecting the two 160 MVA transformers. Also these two 160 MVA transformers 132 kV side are just going to the 132 kV bus as like as the incomer of the 132 kV system, and this 132 kV from 132 system we are connecting to 50 MVA transformer, and 250 MVA transformers are just 50 MVA 132 by 33 kV, and these 33 kV systems are just outing from there and fit by help of a cable per phase, both cable, single core cable we are connecting to the 33 kV indoor breaker, and 33 kV indoor breaker incomer 1, incomer 2, and from here the 77 or 88 number of feeders we are just connecting. For the bus protections we are connecting the earthing transformers with the separate individual bus. For transformer 1 we are connecting the ET1, from transformer 2 bus we are connecting the ET2, and for the station service purpose we are also connecting a station service transformer 315 kVA transformer or 630 kVA transformer. As per our load requirement we are connecting from both sides of the bus for the reliability of the network or the smooth running of the substations. And also for the power factor development or voltage enhancement or improvement of the quality of voltage, we may connect the capacitor bank with the main bus 1 and also the main bus 2. Main bus 1 and main bus 2 are connected by the bus connector in between 50 MVA 1 and 50 MVA 2. So this is our GIS substations. All the things are inside. 220 kV are inside, 132 kV are inside, and 33 kV breaker are also the indoor type breaker. So friend, if you interested to show my video, please subscribe my channel and share my video with your friends and colleagues for more updated technical knowledge, because the GIS systems nowadays most and more advanced technology. By help of these GIS systems we can just enhance our knowledge for the development of electricity, because by help of the if you know the GIS systems, because AIS systems will not be there, because the GIS system lots of advantage are there. The dielectric strength of the SF6 are more than from by the year, so its reliability and its stability is more than from the AIS system. And for the financial burden, the land requirement is very less for the GIS system, but for AIS system land requirement is more. If you want to know details about the GIS, please see my previous video. The details has already been given there. Thank you friend, thank you very much for watching my video. Thank you very much.